Now that we have our models registered, we can take a look at the model management capabilities. So from the upper left menu, I can select the Manage Models part. And in here, I have the option of browsing the projects or the individual models. And by browsing the projects, it's easy to find the project I was working on in Model Studio. So the HMEQ project, we had worked there. And here I find the two models that I recently registered here. So the gradient boosting and the scorecard model that I developed in the previous phase. And by clicking at these, I could get the details about the individual models. If I select particular models here, I can compare them. And this applies also to maybe the versions of the same model. So if I retrain a new version for the gradient boosting, for instance, I can compare the new and the old versions against each other. And here I have different fit statistics. So, for example, Gini's and KS statistics for the models I'm comparing, and the different assessment plots. If I would like to retrain a model, I can go back to the Model Studio interface, or if I just want to set a new table that I want to retrain against, I can retrain a select model and retrain here, select my data and hit send. So the project will run and it will return a new version here in a while. And then I can just browse all the versions I have available to get different versions visible here as well. If I would want to do some type of testing for the models before, for example, publishing them, I can run them here. So I can define a new test, select a name for it, choose the model I want to use. So let's say I want to use the scorecard model. I define an input table. And let's just use the same one again, but obviously you would have a separate test set maybe that you would use for testing purposes. And there we go, and then I just select some output data library, so your personal CAS library will do fine. Then by hitting run, the scoring will happen, and the data is sent to the model, and the data is scored and retrieved here in a second. Okay, now we have the results ready, so we can view the results. And I get the output data right here. And if I would like to visualize them further, I can always use the saved data that is behind the scenes in my personal cache library and build different types of visualizations out of it if I want to do some type of a standardized report, for example, for the model. So I can build the report ready and just refresh the data when I have a new test set ready. If you want to follow the performance of the models over time, it's quite easy to do a performance definition. The first thing you need to do is jump to the Properties tab and then fill out this information. So set the default training table to target variable and the target event value, which in this case is 1, the target levels and the output event probability variable. Then we can go to the Performance tab, and I have the performance definition ready here, but let's see how that is built. So the first thing is setting up the performance definition name, then selecting the tables that actually contain the information about the model performance. So you would have some type of a job in the background ready that would score or save and score the information from the models to a particular library, and those tables then would have a particular prefix that would identify the right performance measuring tables. And in my case, it's these HMEQ res tables that are the correct ones. And I just input those information, and that's pretty much the things I need to fill out. You can still check these settings. So for me, the system scores the data. I have the current champion model as the model I want to use for the performance definition, the input variables, the output variables, and the target properties then come from the properties tab. After you have saved the definition, by hitting run now, the machine calculates the performance measurements here, and you get these nice visualizations about how the performance has evolved over time. If I would like to do some type of alerts based on the performance, I could do those customized reports that I showed previously in the visualization interface. So you can do alerts from there, and actually you can even create your own custom performance reports and bring them here in model management. So you're able to customize this view as you wish. So you don't need to use these ready-made repos if you don't want to. Here's an example of a custom performance report, and now I'm in the visualization interface and I have built myself a custom report that I can use to monitor the performance of the model. And I have some scored data. I have scored through the predictive model. And here on the left, you can see the classification results. So most of the predictions have been as 0, and some of them has been as 1. So a high risk here. And with the blue and yellow color, you can see the actual results then. So there are some cases where we have predicted that the loan would be bad, but then the actual result has been good. And the other way around here, so the classification had been that it would be a good loan, but it turned out to be a defaulting customer. Then here in the middle, I can see the distribution of the event probability. And by combining these two information, we can produce a chart like this, where we see how the model is performing in the different confidence brackets. For example, here, in the 90 to 100% confidence bracket, almost everything, so 98% and little more, is classified as bad. So the model is performing really accurately. And in the other end, here, when the confidence is or the probability is between 0 and 0.1, almost all the loans are good. And then it gradually increases or decreases as the probability increases or decreases. Another option is to use the workflow tab. And here you can select different types of workflows for governance purposes or for alerting purposes. So I could maybe use this simple model monitor workflow for alerting when the performance of the model decreases below a certain threshold, and send out email or Teams notifications to the right persons when that happens. For governance purposes, you can set up a lot of different types of workflows like approvals and these sorts of things, so that so that models are not taken into production in a random way, but in a governed way that is monitored and has an audit trail around it. And speaking of audit trail, it's really good that there is this history tab also available. So here you can see all the important events regarding the project. So when was the certain versions created, and when those have been maybe replaced by a new version. Therefore, you always know which model has been in production, and you can explain to the auditors why a certain result has been given by a particular model on a certain date. If I wanted to, I could publish the models here straight away. So I could go to the Models tab and select the model I want to publish, give it a name, so let's say GB HMEQ, and select the publishing destination. So I could have a different type of destination configured, like the microanalytics service, which is a real-time engine that we can use. We have also other types of publishing destinations for batch scoring, for example, available. And I can hit publish, and soon I will have a REST API ready that I could call and have the model already functioning. Okay, let's look at how the model functions now that we have published it on the mass engine. So I'm here now in a Postman application that I can use to test out any kind of REST APIs, basically. And here you see the address I'm using for the REST call. And as you see, I have my GB HMEQ model specified that we published just a moment ago. And the input data that we use to create the new score for the model is here. So here is the every input variable that we need, and notice how we don't need to create the principal components here. We can just provide the original inputs that we use to train the model, and logic to calculate the principal components is included in the model package. And as we send this, we get a response back in a couple of milliseconds, so pretty much instantly. And here we see the model predictions. So it seems that this would be a good customer, and we can grant the loan. Let's see what happens if we change some of the values. So let's say the years on job would be 0. There would be number of delinquent credit lines. There would be a lot of derogatory reports. It would be quite a high loan amount. There would be a lot of existing mortgage, for example. Let's see what happens. Yeah, in this case, we score the applicant as bad, and we shouldn't give this applicant the loan, as the probability of default seems quite high. Usually, a single model is not enough for automating complex business processes. So that's why we have built in decision management capabilities right into the platform. And you can find those under the Build Decisions interface. Creating a new decision is very straightforward. You hit the New Decision button, give it a name, and hit Save. So let's see how we can build the decision flow. So let's add a rule set as the first item to the flow, and I have this rule set ready about a high loan amount, and let's check what that does. So I have defined a simple rule that if the loan amount is greater than 75,000, we want to assign a flag variable of amount too high as true to indicate that we don't want to score this type of loan with our predictive model, but with some other way or deny them completely. So this is a handy way of creating logic around the predictive model. And it's simple to create these rule sets with these rule builders, and pretty much the only thing you need to do in addition to that is set the variables here. So you can either add new custom variables or add data tables to add many variables at once. Okay, so let's go back to the decision flow. And based on now this result, we want to add a branch. And it's a yes or no branch. In this case, we could add different type of ranges and so forth. But in this case, we want to add a yes or no branch. And we have a value we want to check. So either it can be yes or no. So if it's if the amount too high is true, then we go to the yes path, and if it's not true, then we go to the no path. And if the amount is not too high, we want to use a model that we have built previously. So let's select the model we registered previously. So I will find the project I have, so the HMEQ project, and select let's select the gradient boosting model in this case. And for the other path, we can add a rule set again, and let's add just a simple denied variable basically, or a rule set here to the flow. Okay, we have the logic ready. We can now save this, and after that we can publish these the same way we could publish individual models. So we can publish them to the real-time engine or the batch engine and get the scoring APIs straight away. So here I could select the mass engine and publish the decision flow. Let's not do that yet. Really great way to try out the decisions and understand how the decision will behave in a real setting is the scoring tests we have available here. So we did that also for the simple model, but we can do those also for the decisions. To specify a new test, you can hit the new test button and give it a name and the input table you want to score. So if you have some type of a standardized test set you want to run every time you have updated your model, for instance, you can run the same test set again. And once the scoring is ready, you can browse the results from here. And you get obviously the output data, so and you can take this to the visualization interface and build any kind of comparison reports with other models or decisions. So you can do like A/B testing, for example, like which model or decision behaves in a way that might suit your business the best. And it's good feature as well here, the analysis and plot interface here. So this gives you the ability to track the decisions. So how many of the customers you would score with this type of decision. So how many of those customers would end up in different types of buckets. So this gives you a good way to visually see that the different flows in the decisions make sense and don't end up with maybe some unintentional results.